What's up, you mathletes? Here we go. This is 2.2, solving absolute value equations and inequalities. We're going to start off with just the equations today. Let's do a little bit of review. What is absolute value? It's a number's distance from 0 on the number line, or it's also the positive version of any number. So these are two ways that people think about it. So here you see these lines, that's the absolute value. If you're going to take the absolute value of 5, that's going to be 5 because the number 5 on a number line is 5 units away from 0. That's the number's distance from 0 on the number line. It's also the positive version of any number, so the positive version of 5 is 5. If you take the absolute value of negative 5, then it's also 5. So because negative 5 has a distance from 0 of 5 units. That's how far away it is on the number line. It's also the positive version of negative 5 is positive 5. So you can see there are two numbers that give an absolute value of 5. That's going to be important to think about when moving forward. Here's another. This might actually be kind of new for people because it's this section is going to be the first section whereby you might find that you're solving equations and you get actually multiple answers. There's often in Algebra 1, when you're just dealing with straight lines and linear equations, there's only one answer, usually. But here, we're going to find that there's actually multiple answers, maybe 2 answers, maybe 4 answers, maybe 10 answers. There's lots of solutions. There could be lots of solutions. So we need a good way. We need to get methodical about how we express it. The solution set is often going to be what we're asking for, which is just going to be the collection of solutions. You can see these curly brackets, not square brackets, not straight brackets, but curly brackets is a set. I mean, it's just a collection. And if you're finding the solution set, then you put all the answers, all the solutions into this collection, into this set. So, for example, if you're looking to find all the solutions of this equation, x to the 4th minus x squared equals 0, this ain't Algebra 1 anymore. This is, there are multiple solutions. There are multiple numbers that solve this. So you can list them all here. And you can see there's actually 3 of them, 1, negative 1, and 0. They all work. They're all solutions, so we put them in a solution set. Sometimes we're even given an equation you can't solve, you can't find any answers to. And that's okay. That's like the way we express that is an empty set, a set with no solutions. So it looks like this. You can see the same curly brackets right here, and there's nothing inside. That's because there's no solutions. There's nothing there. What's the answer? Nothing. There's also a symbol that's often commonly used. It's like a circle crossed out. There's nothing there where there are no solutions. So, for example, x squared plus 1 equals 0. There's no real number that will actually satisfy the equation. No number at all. So what is the solution set? It is empty. There's nothing there. Check this out. Fun fact, you could actually follow all the rules and actually get wrong answers. Here's what it looks like. Technically, it's called an extraneous solution, which is a number that is algebraically found to be a solution, but when checked is actually not a solution. Like you could do all of the right things, all the things that I tell you to do, or all the algebraic techniques that seem to be okay, and then all of a sudden arrive up with answers that are actually not true. So, for example, this, and I will describe to you exactly when that might occur, so you don't have to like doubt math or whatever. Square root of 8 minus x plus square root of x is equal to 0. And what is the solution? You might think that this solution, like the algebraic techniques, might lead to an answer of 4. And then when you check it, actually 8 minus 4 is, like you check the number 4 back into the original, 8 minus 4 is 4. And so you get square root of 4 plus square root of 4, that's 2 plus 2, and that doesn't equal 0. So actually, as the number 4 is an extraneous solution. You derived it using good algebra techniques, but when you checked it, it's actually not a solution. All right, so now that we have that vocabulary at our disposal, let's solve this. So solve the absolute value of x is equal to 5. So you have to ask yourself, like, what number, when you take the absolute value of, you get 5? What we did up here, we found that there's actually 2 numbers that when you take their absolute value, you get 5. So anytime you see an absolute value, in order to undo the absolute value, you know you have to undo addition with subtraction and undo multiplication with division. Well, the way you undo an absolute value, the way you get rid of it from an equation, is you have to split it up. You have to consider both the positive and the negative versions. X could be 5 or X could be negative 5. And I think it's a really great way to show your work with the two arrows. Like this one statement leads to two statements. So X equals 5 or X equals negative 5. And there's a solution set. You put it in curly braces. Now, check this out. What if you're going to try to solve the absolute value of X equals negative 5? Basically saying, excuse me while I drink my Starbucks water. I didn't really buy it at Starbucks. It's just the water bottle. It's tap water. Okay, so let's say you've got the question you're basically asking yourself is, when you take the absolute value of what number will produce negative 5? And you can't take the absolute value of any number to get negative 5, not even negative 5, because that, it belongs over here. It's a solution over here. There's no real number whose distance from 0 on the number line is negative 5, because you can't have negative distances when you're talking about that kind of thing. So there are no solutions, and the empty set is like what you would report on alex.com, or what you would say the answer is. There are no answers. This is a set, a collection of numbers, and there's nothing in it. It's like an empty grocery bag. You got nothing inside. So, red flag. Anytime you take the absolute value of anything, even more complicated expressions like x squared, like the absolute value of x squared minus 2x plus 3. If you're taking the absolute value of all of that and you're trying to get a negative number, you can't do it, because that's not how absolute values work. So there's your red flag you can look for, and it'll come up with some frequency. All right, so let's solve this. Absolute value of 4x minus 8 equals 12. Well, to undo absolute values, you have to split it up into two parts, the positive version and the negative version. You can see I rewrote 4x minus 8 twice. 4x minus 8 equals 4x minus 8 equals. And here's the positive version, positive 12 or negative 12. So any numbers, when you solve these, you solve them just like regular linear equations. You undo the subtraction with addition. You undo the multiplication with division. And you get x equals 5. You get x equals negative 1. And so the solution set actually has two solutions in it, 5 and negative 1. They both work. When you put 5 in here, that's 4 times 5 is 20 minus 8 is 12. And you take the absolute value of 12 and you get 12. What about negative 1? 4 times negative 1 is negative 4 minus 8 is negative 12. And you take the absolute value of negative 12, you get positive 12. So there it is. These are the two numbers that work. And you have to report both of them in order to make sure you get full credit in a quizzing situation, or just mathematically, to show that you've examined all the possibilities. All right, let's check this out. It's a little bit more complicated because we got stuff on the outside of the absolute value and stuff on the inside of the absolute value. But what you've got to do is you've got to get the absolute value. Step 1, get the absolute value all by itself. Step 2, undo the absolute value. Step 3, solve both parts. So step 1 looks like this. Get the absolute value all by itself. Undo the subtraction with addition, adding 9 to both sides. Undo the multiplication. There is unwritten multiplication right here because it's 2 times something, like 2 absolute value. 2 absolute values with this. You have to undo that with division, dividing both sides by 2. Now remember, you have to divide all the terms on both sides by 2, and it gets a little tricky because this entire absolute value is treated like a parentheses. This is one giant term, equals 4x, second term, 26, next term. So you have to divide all the terms on both sides by 2. That's, you don't accidentally divide 5x, the 5 and the 1 by 2. This is one giant term. So absolute value of 5x plus 1 is equal to 2x plus 13. And then now we get to undo the absolute value. Here's the positive version. I've written 5x plus 1 is equal to 2x plus 13. Here's the negative version. 5x plus 1 is equal to negative, and then in giant parentheses, 2x plus 13. So what that looks like is this. You can, combining like terms on both sides, or subtract 2x from here. 5x minus 2x gives you 3x. Undo the addition, undo the multiplication, and you get x equals 4. Over here, again, same thing. One extra step, you'd have to distribute this negative symbol to both terms on the inside. So you get negative 2x minus 13. combine the like terms from both sides, adding 2x, you get 7x plus 1 is equal to negative 13. 7x equals negative 14, or just x equals negative 2. So there's the solution step, the solution set. It contains both solutions. And let's see if you can figure out what this red dot is covering. It is the solution set, and it should contain both solutions that we found. Again, steps. First step is isolate the absolute value, like deal with all the outside stuff. Step 2, split the equation into plus or positive version or negative version to undo the absolute value, and then solve both versions to the inside stuff. Let's see. Now might be a good time to tell you that before living in Philadelphia, I lived in Los Angeles for 9 years. It was an awesome time, wild ride. Actually, not Los Angeles City, Los Angeles County. The city I was living in was Pasadena. But audio check Los Angeles. If you've ever been there, let me know. We can trade LA stories. All right, let's do this again. Solve this. 2 times the absolute value of x plus 1 minus x is equal to 3x minus 4. And you got to check it too. I mean, if the instructions say to check, then you should check. Let's see. Let's do all the outside stuff first. So let's undo this subtraction by adding x to both sides. So you get 4x. And then let's undo the multiplication. And when you do that, you divide all the terms on both sides. There's one term on the left, one term right here, another term right here. And so they all get divided by 2. Now that we have the absolute value all by itself, you can split it up into 2 different parts. You can split it up into the positive version and negative version. And here you can see x plus 1 is equal to 2x minus 2. Subtracting x from both sides and then adding 2, you get x is equal to 3. Over here, when you write the negative version, it's negative and then the entire right-hand side. So that's 2x minus 2. And distributing, you get negative 2x, and then the subtraction turns into addition. You can add 2x to both sides and subtract 1, and you get 3x is equal to 1, or x is equal to 1/3. Now, the instructions say to check, so let's check. You put in 3 into both sides, into the original. You get 2 times 3 plus 1 minus 3 is equal to 3 times 3 minus 4. Yes, that actually does work, because both sides turn out to be 5. However, when you put 1/3 in, it actually doesn't work. Why? Oh no! Oh, this is terrible. You mean we actually found algebraically an answer that it doesn't work in the original? Yep, bad news. So you can see the left-hand side, like if you actually calculate this out, and the right-hand side you calculate it out, that it produces a false statement. No, this is not true. Let's see, this would be 1 1/3, that'd be 2 2/3 minus 3, it's negative 1/3 here, and then 3 times 1/3 is 1 minus 4 is negative 3. So it produces 2 numbers that are not the same on both sides. So there's only actually one answer that works, and it's the one that's over here. We found it over here, we checked it over here, it produced a valid answer. It produces 5 on both sides. So therefore, the solution set only has 1 number in it, not 2. Absolute value can also be used like this. The absolute value of a minus b is the distance between a and b on the number line. So what is the distance between 4 and 6? Well, you can put them in here, and you get 4 minus 6. And that equals 4 minus 6 is negative 2. You take the absolute value, and then the answer is 2. And you can even count it right here. Maybe, I know, of course, it's a little bit easier just to count this. There's 1 distance, 2 distance. But if it's like decimal numbers or really large numbers, then you need a formula to do it like multiple times. Then the way you find the distance is you take the absolute value of the subtraction. The way you could write it here is you could say, like, I'm thinking of a number in my head, and it is a distance away from 5. It is 1 unit away from 5. So the distance between my magic number that I'm not telling you and 5 is 1. And so you can solve this, and there's actually going to be, you can see when you undo the absolute value, you get this. There's the positive version, there's the negative version. Adding 5 to both sides, you get 6, and you get 4. So this is actually two numbers I could be thinking about. Two numbers that have a distance of 1 away from the number 5. And they are 6 and 4. Let's do, here's one more complicated thing. Check this out. So we got absolute values on both sides. This is super complicated stuff. But if you want to undo the absolute values, then you actually have to consider like the plus or minus version over here and the positive and negative version over here. This is the plus and minus symbol. And it means actually it means that this could be positive or negative, and this could be positive or negative. Like when you see the symbol plus or minus 5, that is a list of two numbers, positive 5 and negative 5. If you see plus or minus x, that's two different variables, like positive x and negative x. So thinking about that, there's actually 4 different cases you could take. This could be, the left could be positive, the right could be positive. The left could be negative, the right could be positive. The left could be positive, the right could be negative, and or they could both be negative. And you could write them all out. See, here they're both positive, here they're both negative. Here the left is negative, here the right is negative. And so there's actually 4 different cases. Lucky for us, we don't have to solve 4 equations. If you actually multiply both sides by a -1, over in case 2, you actually get case 1. 3x minus 2 is equal to 10 minus x is actually what you get from both of these cases. If you clear the negative by multiplying both sets of parentheses by -1, which you're allowed to do. So then you get 3x minus 2 is equal to 10 minus x, solving by adding x to both sides and adding 2 to both sides, and I'm doing the multiplication, you get x is equal to 3. So you can do the same kind of trick over here with case 3 and case 4. If the left is negative in case 3, you can multiply both sides by -1 and actually get a duplicate of case 4. So they both converge on this equation right here. 3x minus 2 is equal to negative, and then 10 minus x. Distribute the negative, you get this. Subtracting x, you get 2x minus 2 is equal to -10. Adding 2 to undo the subtraction, then undo the multiplication, and you get x is equal to -4. And so between these two numbers, you can put them in here and say that's the solution set. And actually, all right, y'all, I just want to take maybe 3 minutes or so to teach you some Inspire stuff. So pause the video and go get your Inspire. Getting the Inspire. And now that you're back, you can unpause the video. And of course, you've unpaused the video because you're hearing my voice. So let's go to calculate, and let's type something in. I'm going to teach you how to use the solve function. You're going to type out the actual word solve, because we want to solve an equation. Put a set of parentheses, and inside the parentheses you have to put 2 things. You have to put an equation. The button next to the 9 is the frequently used symbols menu. Frequently used symbols menu. And then we go absolute value of x and equals 5, comma button, x, enter. Let's talk about that for just a second. So you can see here, there are 2 things inside this parentheses. If you want to use the solve command, you have to tell it 2 things. 1, an equation, and number 2, what variable you're solving for. If you don't have both of those things, it's not going to work. It's going to give you an error message. But if you separate them 2 with a comma, and remember the comma button is right next to the letter O, there it is, then it'll solve for you instantly what it is. The absolute value symbol, if you didn't see it, is right next to the 9. I press this button, and it's like a menu, a quick menu of frequently used algebraic symbols. So let's keep on going. All right, let's do that again. Let's type out some more equations. Solve, and we're going to say a set of parentheses, and then go 3 times the frequently used symbols menu. Already has absolute value. You can just hit enter because it's already selected. 3 absolute value of x, and then go to the right of the absolute value and do minus 5 is equal to. The equal to symbol is right underneath control. Comma x. The solve command needs 2 things, an equation and what you're solving for. Separate them with a comma. Hit enter, and you get, as we saw in the notes, x equals -4, x equals +4. I'm going to hit the up arrow twice, and it's highlighting solve. And if you hit enter, then that brings it down to the next row. It copies and pastes it for you, basically. So let's change it around to be the next example in the notes. Absolute value 4x minus 8. Equals 12, comma, x. Equation, comma, what you're solving for. You hit enter, x equals -1 or x equals 5. Up arrow twice to highlight it, hit enter, and then you can see we've got, it copies and pastes it for you. Let's change it around a little bit more. And let's go to the, let's see, absolute value of 4x minus 7 plus 10 is equal to 2. Solve it for x, and you actually gives you false. It says you can't solve it for that. There's no solutions. Empty set is the answer, which we found algebraically. All right, solve absolute value of 3x minus 2 is equal to the absolute value of 10 minus x. And I'm going to leave it off here. I want you to type it in, and I want you to find out what the answers are. And I'll see you in class.